Alrighty, welcome to section 11.5. This is one of my favorite things in the whole book, actually. So it's dividing polynomials. You'll notice that in your book there's actually a section on long division. We're going to skip that part of this section, but we're going to cover the rest of it, and I'll adjust the homework accordingly. So the only vocab is one that I've created or made up for you. It's not actually in the book, but it will help you remember something, and it will be easy that way when I say it to you, you know what I'm talking about. The butterfly technique. So this is used when dividing polynomials by a monomial. So you divide each term of the polynomial in the numerator by whatever is the monomial in the denominator individually. So let me just give you a quick example. A plus B plus C divided by D. Okay? The reason I call it the butterfly technique is because you're going to divide everything in the numerator by D. So the first thing you're going to do is divide A by D. So that's going to give you A over D. Plus, then you're going to divide B by D. So that's going to give you B over D. Then you're going to add on C over D. C over D. Okay? And now obviously A, B, and C can be any pieces, any terms, and D could have to be a monomial, but it could be more than one thing. It could be like 8xy or something like that. So the numerator of all of these is the same. It's D separated, and the denominators, God, I can't talk. The numerator of each of these three is different. It's the original three pieces from your numerator, but they all do share a denominator. So because they had the same denominator to start with, they've been separated out now into three separate pieces. So I call this the butterfly technique. It kind of looks like a little butterfly when you do this, especially if you do it all in one thing like that. And it just helps me easily identify and say what you did wrong if you messed up. So a lot of times you might just divide the first thing by D and leave the second two alone, or divide the last one by D and leave the first two alone. You have to remember to divide every single thing by D. Okay, problem solving tips. There are three main ways to divide complicated polynomials. Well, if it's dividing by a monomial, you use the butterfly technique like we just said, but now we're talking about polynomial divided by polynomial. The first one is something we're going to use, is factor and cancel. So you already saw this a little bit in the previous video. If there's a numerator and a denominator, factor both of them as much as possible and cancel out any terms that they have in common. Okay? The second method that's covered in this chapter of your book is called long division. Now you learned long division back in like elementary school, right? You divide two numbers that don't go into each other very evenly. You have to carry out this long process and you get a remainder. You can do the exact same process using variables as you learned in elementary school using numbers. However, this is a topic that's explicitly covered in Algebra 2. And so we're going to, for now at least, postpone it and not talk about long division, so I will not assign those problems. The third way to do this is called synthetic division, which is not in this chapter, but I thought I would mention it since we're kind of talking about all these topics in the first place. So synthetic division, along with long division, will be covered in your Algebra 2 class coming up in a couple of years. So in the meantime, we're just going to do the factor and cancel technique. So anytime you're simplifying a problem that has a polynomial in the numerator and a polynomial in the denominator, you're going to factor and cancel as much as possible and use your exponent rules if you need to. And if there's nothing you can factor and cancel, then you just say it's already simplified. Okay, so factor, find each quotient. Notice that the word or the symbol divided by is the same as doing a fraction bar. So let me rewrite this as a better and easier way to see it. So the numerator is 20x squared plus 12x. The denominator is 4x. Okay, so that's how you might see it written. And now the trick here is the butterfly technique. So we're going to go like this. That squared's part of it, of course. So we got the 20x squared divided by 4x plus, and then this wing of the butterfly, we've got the 12x over 4x. Okay, so our answer then, 20 over 4 reduces to 5. X squared over x reduces to x. Plus 12 over 4 reduces to 3. X and x cancel. So our final answer is 5x plus 3. Okay, this is useful because it helps you break down basically any polynomial that's being divided by a monomial. That's pretty much all there is to it. We can write an excluded domain like x cannot equal 0. It becomes tedious to write the excluded domain on every single problem that you do, so a lot of times it's just assumed. You don't actually write it down, it's just assumed that anything that would make the denominator 0 is going to be excluded. I think your book even says at some point you can stop writing it as long as you understand that you can't divide by 0. Okay, let's jump straight down here to number 5. So the first wing of my butterfly looks like this, and if you want to rewrite each wing of your butterfly separately, you can. That's a really good practice, especially at the beginning. So 12p cubed r squared divided by 6p squared r, plus the next wing of my butterfly looks like this, 18p squared r divided by 6p squared r, minus the last wing of my butterfly here is going to be the minus sign included, 6pr over 6p squared r. Okay, first term, 6 and 12 reduced to just being a 2. P cubed over p squared is just p, and r squared over r is just r. So 2pr is my first term, plus 18 over 6 reduces to 3. P squared cancels p squared, r cancels r. So just 3, that's it. Everything else canceled. Here, cancel, cancel. Minus 6 over 6 is 1. P over p squared is going to give me a p left over in the denominator because the bottom is 2, the top has only 1, and then the r's cancel out. So final answer, fully simplified, is right there. Okay, here's a little bit more practice. Those were all dividing by a monomial, so using the butterfly technique. These are all dividing by a polynomial, in fact a binomial. So we're going to try the factor and cancel technique. This numerator here, we can factor it, and then in the denominator I'm going to have n plus 4. Now, in order to cancel something out with an n plus 4, it needs to be exactly the same, which means it also needs to be n plus 4. So that gives you a major hint when you're factoring these quadratics. If you get one that's particularly challenging, you should kind of recognize, hey, I'll bet that n plus 4 is one of my factors, so what should the other factor be? Well, in this case it's n minus 5 because 4 times negative 5 is negative 20. But it's kind of a major hint here that this is going to cancel out. So final answer, n minus 5. Let's jump down to 15 because this one has a 2 in the front. So we factor. Maybe you're really stuck, you're not sure, oh man, I don't know what to do. Well, look at the denominator. The denominator is 2c plus 1. So what do you think one of these is going to be? Probably 2c plus 1. Let's not put it in just to make sure yet, but to multiply to give me 2c squared, it's definitely 2c and c. To multiply to give me negative 3, it's definitely 3 times 1, right? So let's try and assume that they were correct, plus 1 minus 3. And let's just verify this works. So on the outside, I get 2 times negative 3, that's negative 6c. On the inside, I get plus 1c. And indeed, those two combine to give me the negative 5c that I need as my middle term. So I can cancel out in the denominator 2c plus 1 and 2c plus 1. So my final answer is c minus 3. Something critically important to keep in mind and remember that I haven't mentioned really explicitly right now is you can't cancel out bits and pieces. So for example, you can't just be like, oh look, there's a 2 and there's a 2, let me cross them off. Because it's the entire numerator being divided by the entire denominator, not bits and pieces of the numerator divided by bits and pieces of the denominator. So you cannot, let me make that emphasize, you cannot just cancel bits and pieces like that. Okay, last one here. This is actually 4 terms, so it's not going to be quadratic factor, but you can see if they have anything in common. Let's take a look. So x in the first one factors leaves behind x squared minus 3x. Actually, we take out an x squared, huh? So that's wrong. The first two terms have in common an x squared, leaving behind x minus 3. Minus, okay, the next terms, what do they have in common? A 6x and a 20. They both have at least a 2 in common, so we take out a 2, leaving behind 3x plus, no, yeah, plus 10, because I took the minus sign out, all divided by x minus 5. Now when you're factor by grouping, normally this piece right here and this piece right here will match up and be the same, yeah? But in this case, unfortunately, they do not match up, and so this we would have to say is already simplified. And there's nothing we can do. It turns out in this particular problem, the correct way to do it is to solve it by long division, but since we said we're not doing that, we can check the factoring method. If it doesn't work, then we say it's already simplified. Let me make one extra note here about this last one, number 17. The techniques that we've learned so far were the factoring quadratics and then factor by grouping here, which clearly did not work. However, There are other ways to factor trinomials that we haven't covered this year, so I want to mention, in case anyone's looking at this numerator is factorable, actually, and x minus 5 is one of the factors. However, it involves a technique that we haven't covered yet this year, and so you can just try to do the techniques that we've learned, and if it doesn't work according to those techniques, you can say it's already simplified. That doesn't mean it's like the fully right answer, but it means that it's the best you can do with what you've learned so far. So just to clarify that. Okay, that's it for this video. I'll see you in class.